Hello everyone, this is Dr. Sandeep Kumar, Assistant Professor, Ramjas College, Delhi University. So I welcome you back in the lecture series on heterocyclic compounds. In heterocyclic compounds, till now we have discussed different type of heterocyclic compounds. In the series, first we discussed about pyrrole compound, then furan compound, and thereafter we discussed about thiophene compound. In these compounds, we have discussed in detail synthesis of these compounds by using different methods, then structure of these compounds and their physical and chemical properties. Thereafter, in the very last lecture, we started with pyridine compound, and in pyridine we have discussed the basic introduction of pyridine compound. Thereafter, we discussed about the structure and aromatic nature of pyridine compound, and we found that the structure of pyridine compound has 6 pi electrons, and due to 6 pi electrons it follow Huckel 4n plus 2 pi electron rule, and that's why the compound is aromatic in nature. So in today's lecture we are going to start with the physical properties of pyridine compound. So pyridine is a colorless compound. It is hygroscopic liquid, that means it can absorb the water from the atmosphere as well. So it has boiling point around 388 Kelvin. Further, the compound has very distinct and very unpleasant odor, and the compound is miscible with water and most of the organic solvents. Since pyridine react with sodium very violently, that's why it is typically dried using sodium solid potassium hydroxide or barium oxide. So after physical properties, we are going to discuss the synthetic method which are used for the synthesis of pyridine compound. So in the methods, first of all we will discuss the synthesis from 1,5-dicarbonyl compound, then the synthesis from pentamethylene diamine hydrochloride compound. Then we will discuss the synthesis from pyrones, thereafter synthesis from pyrrole compound, and then synthesis from picolines. After this, we will discuss the two named reaction for the synthesis of pyridine compound. The first named reaction will be Hentz synthesis of pyridine, and the second named reaction will be Guarsky synthesis for the pyridine synthesis. So let's start with the first synthesis for the pyridine compound. So the first synthesis which can be carried out is here. In this case, we use 1,5-dicarbonyl compound as the starting precursor, and the reaction take place in two steps. In the first step, the ammonia will react with 1,5-dicarbonyl compound, and which produce 1,4-dihydropyridine derivative, and this 1,4-dihydropyridine derivative will be oxidized by using different oxidizing agent into pyridine derivative. If R is hydrogen atom, then the molecule will be pyridine itself. So the mechanism of this reaction can be understood like we have 1,5-dicarbonyl compound and we have ammonia. So in 1,5-dicarbonyl compound there is electrophilic carbon of carbonyl group. So on the electrophilic carbon there will be attack by the ammonia nucleophile, and this kind of reaction is nucleophilic addition reaction. So after nucleophilic addition reaction we will get this tetrahedral intermediate, and from this intermediate there will be dehydration take place, that means elimination of water molecule will take place and we will get this intermediate. And in this intermediate you can see there is amine group and carbonyl group in the same molecule. So that's why there will be intramolecular nucleophilic addition reaction take place and it will convert into this cyclic intermediate. And in the cyclic intermediate there will be dehydration take place to get 1,4-dihydropyridine derivative. And this 1,4-dihydropyridine derivative on oxidation will produce pyridine derivative. So this is the mechanism for the synthesis of pyridine or its derivative by using 1,5-dicarbonyl compound as the starting precursor. The alternative method for the synthesis of pyridine derivative from 1,5-dicarbonyl compound is also this one. In this method we use hydroxylamine hydrochloride in place of ammonia, and on reaction with hydroxylamine hydrochloride it will produce an hydroxyl intermediate, and from this intermediate after dehydration we will get pyridine derivative. The beauty of this method is that there is no need to use oxidizing agent that was used in the previous case. So in this case we have to use oxidizing agent for the oxidation of 1,4-dihydropyridine into pyridine, but in this case there is no need. In fact, the conversion of this intermediate will take place into pyridine by only dehydration step. Then the second synthesis for the pyridine molecule is synthesis from pentamethylene diamine hydrochloride. So when pentamethylene diamine hydrochloride heated, it undergoes cyclization to form piperidine molecule, which can then be converted to pyridine either by oxidation with concentrated H2SO4 at 573 Kelvin, or we can use catalytic dehydrogenation reagent like palladium on charcoal. So in the reaction you can see that the compound is pentamethylene diamine hydrochloride, and on heating there will be elimination of hydrochloric acid and ammonium chloride from this molecule and it will convert into piperidine. Then this piperidine on treatment with concentrated H2SO4, or we can also use palladium charcoal, will produce pyridine as the final product. The third synthesis for the pyridine derivative is from pyrone compounds. So for the synthesis we can use either alpha pyrone or we can use gamma pyrone. So in the synthesis alpha or gamma pyrone are transformed into their corresponding pyridones that can be either alpha or gamma based on the starting precursor. So for the synthesis we have to heat pyrone derivative in presence of ammonia, and that will produce 2-hydroxypyridine as the final product. So the mechanism of this reaction can be understood like in the starting precursor, that is pyrone, there is electrophilic carbon of carbonyl group, and on this electrophilic carbon there will be attack of ammonia molecule. So this attack is kind of nucleophilic addition reaction. So after nucleophilic addition reaction we will get this intermediate, and this intermediate will tautomerize into keto form. As you can see in this intermediate there is alkene bond and hydroxyl group, so it is in enol form, and this can be tautomerized into more stable keto form, and further from the keto form there will be intramolecular nucleophilic addition reaction by amine on the electrophilic carbon of carbonyl group. So after intramolecular nucleophilic addition reaction, we will get this cyclic intermediate, and from the cyclic intermediate there will be dehydration step will take place, and we will get this 2-pyridone, and this 2-pyridone is tautomerize into 2-hydroxypyridine, which is our final product. Then the synthesis of pyridine can be carried out from pyrrole molecule. So for the synthesis, we have to use dichloromethane in presence of base, that is sodium ethoxide. So when we heat pyrrole in presence of dichloromethane in sodium ethoxide, then there will be formation of pyridine as the final product. The same kind of synthesis we have discussed in pyrrole molecule. So when we were discussing about pyrrole molecule, then what we found that when pyrrole is treated with chloroform in basic condition, then it produced 3-chloropyridine. But if we use dichloromethane in presence of chloroform, then the final product will be pyridine molecule itself. Then the next synthesis of pyridine can be carried out by using picolines. So picolines are the compounds which have methyl substitution at pyridine ring. So if the methyl substitution is at alpha position of pyridine, then the compounds are known as alpha picoline, and if the methyl group is at beta position, then the compound is known as beta picoline, and if the methyl group is at gamma position, then the compound known as gamma picoline. So we can use either of the picoline derivative, means alpha picoline or beta picoline or gamma picoline. So any kind of picoline under oxidation with potassium dichromate in acidic condition will produce picolinic acid, and this picolinic acid on treatment with calcium oxide on heating will undergo decarboxylation reaction. Decarboxylation means there will be elimination of CO2 molecule, and we will get pyridine as the final product. Then we are going to discuss the synthesis of pyridine by using Hentz synthesis. So the method is very common method, and it is also adopted by commercial level, and in this method there will be reaction between beta ketoester like ethyl acetoacetate and ammonia and acetaldehyde. So these three components will undergo condensation reaction by using a sequence of reaction condition, and they produce 2,4,6 trimethyl pyridine compound. So the sequence of reaction condition can be break down like this. We have ethyl acetoacetate, 2 molecules of ethyl acetoacetate are needed for this synthesis, and this ethyl acetoacetate on reaction with ammonia and acetaldehyde at high temperature will produce 1,4-dihydropyridine derivative, and this 1,4-dihydropyridine derivative on reaction with nitric acid will undergo oxidation and will produce pyridine derivative. Then the ester substitution on this pyridine derivative will be hydrolyzed into acid by using basic condition, and then the carboxylic acid on treatment with calcium oxide on heating will undergo decarboxylation reaction, and the final product will be 2,4,6 trimethyl pyridine, which is also known as collidine. So the mechanism for the Hentz synthesis can be understood like we have ethyl acetoacetate and we have ammonia. So ammonia will undergo nucleophilic addition reaction on the electrophilic carbon of this carbonyl group. So after nucleophilic addition, we will have a tetrahedral intermediate, and from this tetrahedral intermediate there will be elimination of water molecule, and we will have enamine as the intermediate. The second molecule of ethyl acetate will react with acetaldehyde, and there will be kind of aldol condensation reaction between these two components, and overall there will be dehydration, or we can say elimination of water molecule will take place, and we will have alpha beta unsaturated carbonyl compound as the intermediate number 2. So in the step 1 and 2 we have synthesized two intermediate. First is enamine and the second is alpha beta unsaturated carbonyl compound. So in the third step there will be reaction between these two intermediate number 1 and intermediate number 2. So the reaction is kind of Michael addition, that is 1,4 addition reaction. So enamine will attack on the double bond of alpha beta unsaturated carbonyl compound and will produce this intermediate. So from this intermediate there will be intramolecular proton transfer reaction will take place, and we will have this intermediate. And in this intermediate we have carbonyl group in the same molecule and we have amine group. So there will be nucleophilic addition reaction will take place between these two functional group, that is carbonyl group and amine group. So after nucleophilic addition we will have a cyclic intermediate. Then from this cyclic intermediate dehydration will take place and it produced 1,4 dihydropyridine as the intermediate. So this 1,4 dihydropyridine will be oxidized by using nitric acid and it will convert into pyridine derivative. Then the ester substitution on this pyridine derivative will be hydrolyzed by using basic condition, and then the hydrolyzed acid will undergo decarboxylation by treatment with calcium oxide on heating, and the final product will be 2,4,6 trimethyl pyridine. The next name reaction for the synthesis of pyridine is Guarsky synthesis. So in this synthesis, cyanoacetamide, this molecule, react with a beta diketone in the presence of a base. The base which we can use is potassium carbonate in acetone, or we can also use piperidine in ethanol. So by using this condition we will have the synthesis of pyridine derivative, and the beauty of this synthesis is that the synthesis is also used for the synthesis of pyridoxine compound, that is vitamin B6 compound. So the mechanism of this Guarsky synthesis can be understood like in the presence of base, since we are using potassium carbonate, there will be abstraction of alpha hydrogen from the cyanoacetamide component, and there will be formation of carbanion, and this carbanion will attack on the electrophilic carbon of carbonyl group, and there will be nucleophilic addition reaction. Then after nucleophilic addition reaction we will have this intermediate, and from this intermediate there will be intramolecular nucleophilic addition reaction between amine functional group and carbonyl group. So after intramolecular nucleophilic addition reaction we will have a cyclic intermediate. So from this cyclic intermediate on heating there will be dehydration will take place, and we will have this pyridone derivative, and this pyridone derivative will undergo tautomerization to produce 2-hydroxypyridine derivative. So these were the methods which are used to carry out the synthesis of pyridine or its derivative. Now we are going to study about the chemical reaction of pyridine molecule. So the pyridine molecule show three kind of reaction. Reaction due to its basic nature, then the second type of reaction which are feasible on pyridine molecule are electrophilic substitution reaction, and the third kind of reaction is nucleophilic substitution reaction. Since pyridine is an aromatic compound, so it is highly stable compound and it resists oxidation at the carbon atom, but the oxidation at nitrogen atom of pyridine is very much feasible, and we will also discuss the reaction where oxidation at nitrogen of pyridine is carried out, but the oxidation at carbon is not possible, and that is why pyridine favors substitution over addition reaction. So let us start with the first chemical reaction of pyridine from the three category, that is basic nature of pyridine. So the basic nature of pyridine, or we can say the basic nature of ammonia or its derivative, is due to presence of this lone pair on the nitrogen atom. So the presence of this lone pair nitrogen atom will make the pyridine molecule as the basic in nature, and since this lone pair can be donated easily for the protonation or for any other electrophilic reaction. So when we have this pyridine molecule on reaction with acid, that is hydrochloric acid, then there will be formation of pyridinium chloride, that is a salt. And in the second reaction, when we have methyl iodide, then this methyl iodide on reaction with pyridine will undergo the synthesis of N-methyl pyridinium iodide, or we can say pyridine meth iodide of this compound. So the next part of basic nature of pyridine and electrophilic or nucleophilic substitution reaction on pyridine will be discussed in the next class. Thank you very much.